Hello, everybody. I guess it's time to start today. Welcome to the Lisp working group session. Okay, I'm Luigi Iannone. Online is also Joel Alper, my co-chair. We have also Padma, our secretary, which is listed among the participants. Do you guys hear me loud and clear? Somebody check.
I can hear you clearly. Thank you, Luigi.
Okay. On the screen right now, you have the note well. You should be used to it. Everything we say is registered in Mitico, is a contribution to the IETF and may be published publicly. Okay. The usual pointers, okay, to the Jabber room, which is actually integrated with the Mitico, the charter, audio and the video stream, and the slides. Everything is on the material page. A quick update. This was 108. We do progress slowly. These are the changes until yesterday. The only thing that really changes is about the BIS documents. We have less threads in the ISG ballot. And actually, during the night, there was an exchange between Albert and Roman. And we have one less red dot in the 6830 BIS document. Okay, so we just need to clear one discussed from Eric in the 6830 and one from Martin in 6833. I guess Albert will speak about that. So, the agenda. As usual, Albert will give us a quick update about the BIS documents. I will open a bottle of champagne once we are done with these two documents. It's been a lot of work, especially for Albert. And then we will have Alberto giving us an update on the PubSub document. Now, in the schedule, we have Sharon speaking third position about network hexagons, but actually he's also speaking maybe right now in the CoEnergy meeting. So if he's late, so running late for any reason, we will postpone his talk later on. Okay, and we will give priority to Albert, which will give us an update on the Matraversal document. Then Dino on the Lisp distinguished name encoding. There has been some discussion about this on the mailing list. And the last talk scheduled today is Jordi, which will show us a real deployment of Lisp on a campus network, as far as I have understood. The long title that you can see is SD Access Practical Experience in Designing and Deploying Software-Defined Enterprise Networks. Okay. Has anybody any comment on the agenda? I take silence for a no. And just to be clear, I think it's better if I run the slides for everybody. Okay. So just give me the time to switch slide deck, and then when you speak, just say next, and I move forward the slides. Okay. Okay. In that case, we will move to Albert. I will stop my camera.
Hey Luigi, good morning.
Morning, Albert. Doing fine?
A little bit sleepy, and that's fine.
I
Very
understand.
early. Yeah.
Yeah, but I mean, our colleagues in US are worse than us as a situation with the time shift. Oops, sorry.
I disagree. The people in Europe is way worse.
Okay, so I'm going to give the, let's call it, traditional update, and I hope that this is the last one because I believe that we are very close to finishing. So if you go to the next slide, please. So as Luigi was saying, we posted three revisions since last IETF for the data plane and 2 for the control plane, and now we are only down to 1 discuss for each document, and the discuss are really, well, I don't want to say minor things because they are discussed, right? But at least they are super easy to fix, and I have already replied to both Eric and Martin. So hopefully they clear the discuss and we're pretty much done. So next slide. So I have one slide per document specifying what has been changed. For data plane, we have pretty much clarified some different aspects. I would say that the most relevant ones are the limitations for ICMP in the case, for the use of ICMP in the case of path MQ discovery, and also clarify that the instance ID is not protected, and when they are carrying VLAN tags on path attackers can change them. And next slide. And then the data plane has more changes. We have removed a bunch of text related to verifying map request, of what was the use, some specification of what you should do when you receive piggyback data on the map request, and we have removed pretty much all the text related to that. We have also elevated a must and a should for the different crypto suits for the map register. Then we have also clarified what happens when the record count, that the record count can actually be larger than the requested count, because you may have more specifics. Also specified better the use of the salt in the KDF mechanism because it was not clear how to use it for different messages. And then some clarifications on how actually map notifies and map notifies acknowledgements are retransmitted. And that's it from my side, Luigi.
Okay, thank you very much, Albert. Is there any question from the audience? Nobody in the queue. Nobody speaking up. Take it as a no, everything is clear. Thank you very much, Albert.
Yeah, thank you.
Alberto, up to you. I'm putting up the slides.
Okay, can you guys hear me?
I can hear you.
All right. I hope the direction as well. And if not, Luigi, you will say, yeah, I love it. All right. Stop. So we, not in the previous IETF, but in the one before, we had a long discussion on PubSub, and we made some good progress. So this is basically to send the update on the document, but especially to discuss with the working group some comments as we go to the early review. And thanks to the chat for facilitating that. That was very useful. So let's go to the next slide. These are the summary of changes since the last version. Basically, the big chunk of changes were about how to establish security associations between the IETF and the map server without requiring to establish one. And the design that we basically wrote down in the document after the discussion with the working group can be summarized in that you use Lisp to establish that security association, and that basically you derive a PubSub key from the ATK that you exchange. And the details are in the document. They are not that complex. That's it on a nutshell. And another minor change I mean, Another thing that we did there was that the nonce that you need to keep on the factor operation has to be for both STID plus EID record. So the previous one, the document was just to define the nonce per STID. Now we are saying that it should be per STID and EID record. So let's go to the next one. And this is what I wanted to bring to the attention of the working group. So we had this like the early review, and I just realized when I was in the slides that the working group was not in CC on the review, although the review has been public in the data tracker, so anyone with interest could have checked that. But I forwarded the review to the working group just in case the other way. But basically, what Chris, the reviewer, was saying, the main point was that he had been looking at different list documents, and he saw that the term nonce is used in the documents and in PubSub in particular as what he understands more as a token. Because we use the nonce, as you know, now we increase them and we compare that the number, the token, the nonce is greater than the previous nonce to prevent reply attacks and so on. And he understands that as a consistency with the IETF security glossary on that RFC. So I'm copying the definition from that RFC, the definition of nonce from that RFC there. And the question I have for the working group is, because this is not only a PubSub thing, so PubSub is just following the way we use nonce in other places in Lisp. So do we believe that the way we use the word nonce is fine on the documents? Shall we rethink that, or shall we just say to reply to Chris that we believe that we are within the definition of RFC 4949? So I'm gonna pause here and see if anyone has any comment on this.
So this is Albert Cabello. So we had the same issue for the big document, but at the end I believe that they accepted the term none because it has been used in the past for so long that it was hard to change. But I don't know if this applies here.
I think it should, right? Yeah,
my take on this is that, my opinion, we should keep nonce. I understand the review, and probably we somehow did not a mistake, what was not the correct term to use for nonce. Anyway, if we change it in this document, we'll be inconsistent with the other documents. And at this point,
yeah, that's true.
Might be something to put this in the document somewhere, just a sentence that says we use nonce to be consistent with the main specs of Lisp. But if we look at the definition, then the RFC 4949 security glossary, this would be categorized like a token. Just state it as it is, but we keep nonce for consistency. A simple sentence to add somewhere, I don't know. Okay. What do you think? Maybe in the security section, or just 2 lines sentence. What do you think?
That works for me, Luigi. If there are no arguments against that approach from the working group, I'm perfectly fine with that. And certainly, I don't want to have to change other documents. I think we can keep nonce as is.
Yeah.
Hello, can you hear me? This is Dino.
Yes, we can, Dino. Yes.
Yeah, I think we shouldn't change it at all. And plus, adding extra sentences with new terminology just adds a term that's not going to be used anywhere. And you know how many occurrences of nonce we have across all the documents? This is just busy work, and I don't think we should make any changes.
So, Dino, your point is that we should probably reply to Chris stating what Albert said before, that we are using nonce and that's what the rest of the documents do, and that's it?
Yes.
Okay. Okay, yeah, I'm fine whatever the working group thinks on this. So we can maybe start with just trying to Chris along the lines that Albert said, and see if he agrees with that, and if not, we can maybe explore what Luigi was suggesting. So I think we have a plan. Okay, so maybe let's go to the next slide, Luigi. So this is the other comment that Chris put on the review that I think is easy to address, that is basically what to do when the value of the nonce says the field space. And here I think the answer is what we have said in other occasions in the past, that the field space will be big enough to accommodate with plenty of updates. And I'm doing some numbers there that I double check like 3 times, but I am sure that they are right still. So if we assume 1 update per XTID record per second, so that's a lot of updates actually. We will, run out of nonsense in I don't know how many years. That's a very big number. So I think that we are probably safe saying that we are not gonna exceed the field space, especially now that we did that change, that the nonsense are per XTID record. So the space that we have is big enough for those updates. And then the last
May
slide
I
is
ask a question?
Of course, yes.
Albert, did you specify the fact that, I mean, maybe it's trivial, but the fact that once you reach the top, I mean, 2 power 64 minus 1, then you wrap around to 0, and then there is the usual thing, you take half of the space before the value is minor, half of the space in the front is an increase. So 0 is bigger than 2 power 64 minus 1. You see, it's around space. Just to state that, yeah, at some point you wrap around, but the space is so huge that you don't have any doubt that is well specified. You see what I mean?
Yes, yeah, you're making a good point. I don't think, I took that for granted, but I'm checking the document right now, and I don't think we specify that. I mean, which is, what you would expect.
Yeah, yeah, I understand. I take it for granted as well, but better be clear.
No, yeah, I agree. Okay, that's a good point. We can make, we can add a sentence for that. That's fine.
Yeah.
Okay, so then Dino, you have a comment?
In previous protocols, when you're comparing sequence numbers that wrap around, you usually look at the old sequence number, and if it's in the upper half of the space, and you're comparing it to a new sequence number which is in the lower half of the space, then the latter is greater than the former.
Right.
Yeah, exactly.
Right.
Exactly.
No, that makes complete sense. Okay. So the very last slide, if we go there, is just to say, so once we put the 2 words about the wrapping nonce, we get back to Chris on the comment he made on the nonce. I don't know what else is to be done on this document. So I think we are ready for last call. So I will open the floor now for anyone to comment on that, or if not, I think it's just a matter of publishing a new version and then sending it to the list for last call.
So I have 2 questions. So the first one is, maybe you meant to say working group adoption. As far as I remember, the document still came again named. Let me check.
No, it's a working group document.
Yeah.
I know that we all miss Vina a lot, but no, it's a working group document.
Yeah. Sorry, that was my mistake. Yeah, I don't know. I open the floor for any comments about last call or on the documents itself.
Last call.
I heard you, Dino.
You heard me. Did you understand?
Yeah.
Oh, okay.
Last call.
Okay, So yeah, that's
Okay.
all I had. Oh, Mohammed, you want to say something?
Yeah, I wanted just to say that I think that the two pending issues are the ones that are raised by I would say by the holistic directory review, and this one are really minor ones that we can really handle. And I think that the document is here since a while, and the many iterations, even if we are a little bit slow in the publishing the versions, I think that the document is really stable enough, and it is really ready for the working class poll.
Okay, thanks
Okay.
for that, Matt.
Thank you very much, Matt.
So that's all I have.
Okay, what I can say is I agree with Matt. The document is stable. If you fix the things that you just discussed, minor things we discussed it today, we can take it to the list for the last call. I mean, okay.
Okay, sounds good. Thanks,
okay?
Luigi. Yeah.
Okay. Thank you very much, Albert.
Oh, thank you.
So did Sharon join us? I would say no. No. So Albert Lopez. We have to make the distinction here. Too many Albert and Alberto. So not traversal. Let me put up the slides. Here we go.
Hello, everyone. Can you hear me?
Yes.
Okay, so I will try to present some modifications that we have done in the draft document in the last IETF edition. Next slide. As I explained it in the presentation of the last edition, NAT is a critical point in current deployments, especially for these mobile node devices that are constantly moving and changing their endpoint connections. The main changes of the draft present in this document are focused on the updates of mappings, like the produced when changing from NAT to no-NAT or changing the RTR. Next slide. As a first step, when an XTR receives a new error log, is to check if it is behind NAT by sending an info request to map server and processing the received info reply. If the device was previously using NAT and the new error log is also behind NAT using the same RTR, we only need to update the catch entry of the RTR by sending an encapsulated map register to the map server through the RTR. For any other scenarios, we need to notify remote ITRs and proxies. In the draft, we point to 6830Bs and 6833Bs and PubSub draft, where I described the current methods to notify mappings updates. But we recommend to use PubSub draft as it is a faster mechanism to notify peers, and it avoids the temporal increase of the path length associated with an ETR disassociation of an RTR. In the draft, we also indicate the option for the devices that can move from NAT to no-NAT, like in the case of Lisp mobile node devices, to use an RTR as an anchor, and in that way avoiding frequent notifications of log changes. Next slide, please. Generally, a mapping update that needs to be notified involves an EID from an ETR that was previously associated with an RTR, and due to it is now using new RTR or a public address, we need to remove this association. The registration process described is based on the EID mobility draft and involves that when a map server detects a change of the mapping, it should notify the removed active error logs by sending an unsolicited map notify. As a change to introduce in the draft to make possible this mechanism, I will explain that the ATR should mandatorily register its local airlocks with the reachability bit to 0. In the previous version of the draft, this was optional. I will provide more details of this mechanism in the following slides. Next slide, please. This scenario consists of two XTRs, A and B, serving the same EID, and both with one interface behind NAT. Next slide. The XTRA changed its airlock, and now it is using a public address, A'. Once it has detected that it's not behind NAT, it registers directly the new mapping to the map server. So now the mapping for the EID is the one showed in the top right, where the orange locators are the ones to be removed. Next slide. As we said before, the map server sends an unsolicited map notify to living active airlocks, in this case, the RTR airlock. Next slide. In this slide, I will try to describe the behavior of the RTR when receiving an unsolicited map notify. Firstly, the RTR checks if any of the local locators associated with the XTR ID of the EID map catch entry, the red one, are present in the record of the map notify. If so, the RTR used the information of the selected locator to forward the map notify to the XTR. To do so, it replaced the destination address of the map notify from the RTR airlock to the local airlock of the XTR. Then it generates a data map notify that forwards to the XTR using the NAT state information of the selected local airlock. Now we are in the else section, where any of the local airlocks are present in the map notify record. This indicates to the RTR that the XTR with XTR ID A has left the RTR. As we cannot authenticate the map notify because the authentication data of the map notify is for the destination XTR, we need to validate its information. So we store the map notify record and request the mapping to the mapping system. The replay is used to validate the map notify, not to insert it in the catch. Otherwise, in the example of this slide, the RTR would lose the state associated with XTR IDB. Once validated the map notify, we can remove from the entry the locators associated with the XTR ID A, indicated in the map notify. Finally, if the catch entry doesn't have any locator, we can replace the catch entry with the map replace record and start to forward traffic to the valid destination airlocks until the entry expires. Next slide. So in the example that we were explaining, the RTR checks if local airlock A, the one in red in the slide, is present in the map notify record. If the airlock was present, the RTR will forward the map notify encapsulated in a data packet to the XTR A. But as it is not the case, this means that the XTR IDA is not longer associated with the RTR. We need to validate the map notify information, so we store it and send a map request. Next slide. The map reply confirms the map notify information. So now we can remove all locators associated with XTR IDA. Here ends the process of unregistration of the XTR IDA from the RTR. Next slide. If the EID is only associated with XTR IDA, when it completes the unregistration process, the EID catch entry don't have any locator, and in that case, we replace the catch entry with the new one. And we start to encapsulate traffic to the new destination. Optionally, we use the mechanism presented in the EAD mobility draft to send reactive SMRs to the remote ITRs that are sending traffic to the EAD through the RTR to notify them that have an old version of the mapping. Next slide. Regarding if an RTR receives an SMR for a served EAD, the RTR will request a new mapping to the mapping system, but it will only replace the EAD catch entry if the received record doesn't contain any locator of the RTR. If the record contains an RTR locator, it means that it exists at least one XTR that is still associated with the RTR. And if we overwrite the entry, we will lose the NAT state used to punch the NAT. Next slide. Until here, we presented the part of mapping updates. Now I will present a couple of more modifications introduced in the draft. The first one is related to the map request replay handling. In the previous version of the draft, it gives the option for an XTR to replay directly to the map request. To do that, it is required that the map server has the information to punch the NAT to forward the map request to the XTR. To do that, the XTR registers to the map server the NAT LCAF address learned in the info request process, and the used RTR airlocks are set to priority 255. When the ETR replaces, it replaces with the set of RTR airlocks. Next slide. As the information stored in the mapping of the map server is not the one needed to forward the traffic, this option is not compatible with PubSub mechanism, which is the one we recommend to use. Also, this mechanism introduces extra state in the NAT device for each map replay. For all these reasons, we changed the draft to make proxy bit to 1 mandatory and not allowing the XTR to replay. Next slide. As a last change, in previous version of the draft, the RTR rewrites the inner header of the encapsulated map register from ETR to local airlock to RTR airlock when sending the message to the map server, and vice versa when sending back the data map notified to the XTR. We consider that this behavior is inherited from the first version of the draft when encapsulated messages were not used, and the rewrite is no longer needed. So with this concludes my presentation. If there is any question or comments.
Any question from the floor?
Yes, I have a comment. I'm also a co-author. This is Alberto Cabellos. I'm also a co-author. And the draft has been, it has at least 2 implementations. It has gone through several iterations. And as far as I know, it is still an individual submission. And I would like to understand if we can move to working group adoption.
Excellent question. I like the work that you did, because this is a nice lab that is really based on the pain you experienced in doing NAT traversal while implementing this, as far as I have understood. So it's a nice piece of work, and has been around for a while. I have only one question. Last time Dino presented also a NAT traversal solution. So Dino, what are your plans about this?
Plan. I'm not going to, I mean, if you're asking my implementation plans, I'm not going to implement it because I think the performance of the system is going to be way worse than what I implemented because of all the intermediate processing of the packets that have to be relayed through the RTR. So that's my fundamental point with the problem. There's too much indirection of messaging that's happening. And there's, I showed you an alternative solution that I believe performs much quicker. And, handoffs are really important if you want fast convergence on our load changes.
So, but let's say what you plan to do with your document, because if you want to push it, I mean, we cannot have two documents that explain two different not traversal property approaches. So the working group at some point has to discuss whether or not merge the documents.
Well, like I said in my presentation at last IETF, whatever the working group wants to do with the document that I wrote, I'll support that. I'm not sure if I'll support a merge because you have to take the pros and cons of each one and merge it to have a sensible design, and that will be a lot of work, and it typically compromises the design. So,
Okay.
We would have to go through a thorough review of the pluses and minuses of each proposal and either decide to go with one or the other, or try to come up with a third option, which is take some of the ideas from here and the other ideas from there. And that's what you're suggesting with a possible merge. But I've never seen that successful before. It always produces something worse than either of the other two alternatives.
Okay.
Luigi, this is Alberto.
Yes, go ahead.
My question is why can we have, I mean, two versions if need be? And the reason I'm saying this is that so the not traversal draft that Albert described, that has been, tested definitively in OpenOverride router and other implementations, and Albert Lopez has, think of all or many corner cases that none of us anticipated. So a fair amount of time has been put into debugging that implementation, so it covers a lot of corner cases. So if Dino has a different
Less
draft
mature in a certain way because it's recent.
No, well, I mean, I'm not saying that. I'm saying that it is a different approach and he's taking different trade-offs. So what I don't understand is why we should. So I think that the draft that Albert just presented is probably the most structured implementation of not traversal because that has been tested in and out. And then Dino is proposing a different approach. I'm not saying it's better or worse. It's a different approach with a different set of trade-offs. So I agree with Dino when he says that trying to merge the two is gonna end up with something that is not gonna make anyone happy. So yeah.
What I suggest is the following. I understand the request from the authors to adopt the document. Okay. And
by the way, I'm not an author of this document.
Yeah. And if Joels agree, what we can do is we can formulate a call for adoption on the mailing list. I just want to formulate it in a way that makes all the participants in the mailing list aware that there has been recently a different approach from not traversal, which is the one proposed by Dino, okay, and comment on that, okay, and let's see what the working group says.
Yeah,
Like,
Luigi, I'll work with you on the wording, but yes.
Yeah, we have to word the call in a correct way, I would say, but it's just to make the working group aware that there is the second proposal, not that in next year somebody says, oh, but there is another proposal, why you didn't do it? Okay, just to be clear on the process. That's it.
Yep. We need the working group to be clear about what it wants, and then we'll move it forward.
Absolutely.
Okay.
Okay.
Okay, thank you.
Thank you for the clear presentation. I did enjoy it. Let's move on. Sharon joined us. So if Sharon is ready, I will put up his slides.
Yes, hi, good morning, good evening.
Hello,
Sorry
Sharon.
for being late, but I think I did a good PR for Lisp.
Excellent.
Took longer than I was planned, but was good interest. So I want to give a quick update on what has changed in Lisp Hexagon since 108. Mostly courtesy of Luigi, Joel, thank you. We had a pre-review of security aspects, and that resulted in some clarification in the wording. Let me just quickly summarize what was the discussion about and what Lisp mechanisms were pointed to mitigate security concerns. One was tapping, the ability to tap into traffic from mobility clients uploading potentially sensitive data. And here the answer is that we use an RTR scheme, meaning all communications are tunneled between the EID and the RTR, between the RTRs, and then between the RTRs and the services, the H3 services. And therefore we can do tunnel encryption. I know tunnel is not the perfect term for this, but these are tunnel routers, but these are more dynamic encapsulations, but we can still use point-to-point encryptions, by default IPsec. But if there is support for more advanced mechanisms, then we can do that on a per tunnel basis without tying the clients which are in cars to services which is in edges or cloud, which have a very different development and update rates. So we're not tightly coupling, but we're doing it by tunnel by tunnel. The next concern was spoofing. And here what we pointed to is that there is a AAA stage where the EID clients are allocated an EID that reflects, it's completely logical and reflects their credentials and affiliations, and also their the kind of channels they are allowed to subscribe to. This is all encoded in the EID. And that EID is provisioned at the RTR, which is the home. So even if it's two homes, you cannot skip between RTRs as you choose. And that's the spoofing protection. You'd have to spoof both the RLOC and the EID, and that should be detected by the underlay network. Same goes for the H3 services. These are provisions for DevOps considerations, and therefore provision at the RTRs. And again, if you want to spoof them, you'd have to spoof both underlay and overlay addresses, and the routers between the services and the RTR should detect that based on double lookup. The next concern was privacy, and here we pointed to the fact that that was the point of using standard Lisp to create the skeleton of this network. And the geo-privacy is protected by the ability of, say, Toyota to bring their own RTR. It will be provisioned to the system. It just has to function like a standard Lisp RTR and support the RFCs that are used in the Lisp hexagons, mostly 6830 and 8373, the signal free. And the H3 services themselves don't have the IP address of the EID clients, so they don't know. They know the EID of the client. They know its credentials, its credibility, but they don't know its real IP address. So we have geoprivacy. The last point was about fake news. What if you spread a bunch of traffic jams and problems where they're not, so you'll have a clear path to work. And here, the explanation was that this is a crowdsourced system, so nothing is set and published to subscribers based just on one account. There has to be multiple accounts. The credibility of the client is encoded in its EID, and its detections are adding or subtracting to its credit score. The credit score based on what it detected versus what other people detected and was verified is passed back to the H3 to the AAA service, to the Diameter server, but not from a specific H3 service, but from all H3 services. So the AAA doesn't know where the client has been. Why did he get these credit score increase or decrease? And that was okay. I think for this examiner, it was okay. So if any questions, I can move on.
Any question from the audience?
All right. So the next topic was, the presentation to COIN, and it has to do with the presentation that Louis featured yesterday about using virtual routing for edge computing and to do concurrency in edge computing. And here we show Lisp Hexagon in two examples to triangulate what's going on here. To try and triangulate, and maybe as a next step, generalize this draft for other edge use cases. And the logic may be interesting to the group, and I can go through it really quickly. I'm not going to repeat the whole presentation, but if you can go down one slide. Okay, so here's the problem. AI needs very heavy processing and high concurrency, which is achieved at the data center using frameworks like Spark or Databricks, leveraging Spine Leaf, Gather for concurrency. But what if we have to process on the edge? I mean, if we don't have to, we will process in the data center. But if we have to process on the edge. Why do we have to process on the edge? There's multiple reasons. Like if you think of a data center as a brain that can think about things and spawn the concurrent load for it takes a few seconds and all that. The edge is more like a spine reaction, an intelligent reaction to physical world activities, and has to respond with a sub-second. The other reason is that if the raw data, the fresh raw data load is too much to upload to the cloud, I have to process it in the edge. And the last is regulatory business reasons. I have to process within the city, within the state, or the metro area, within the carrier, within the private cloud of Toyota, let's say, and therefore I have to do it in a specific location. Also, if I wanna pull as much AI as I can out of the car from the same exact principle of concentrate as much as possible, then I have to do it at the edge. I cannot pull a lot of AI all the way to the cloud and keep only the necessary AI in the car. There's multiple reasons for that. The car is very idle. It has a different depreciation and so on. So this is the general problem statement. And if you go next slide, We gave Nexagon as an example, where the cars are generating, every car generates 4 megabits per second data. So 10,000 cars is 40 gigabits, and that's nothing compared to 100,000 cars. So I have to process it at the edge. I have to react quickly if there is a stroller there, and of course, if I'm an AV, I'll stop. But what about the cars behind me? They should know about it, and so on. And there is Muni and OEM reasoning why you should do it at the edge, and we gave Nexagon as an example. If you go down one more, we gave another example, a cyber example, where terabit switches, maybe hundreds of those, are sampled at 0.1% rate, and to create gigabits per second, and that cannot go all the way to the cloud, and I have to process that in the edge, and we'll explain how we use the kind of a Nexagon-like architecture to do that. So if you go down, okay, this is why Lisp is, if you go down, you all know that. Lisp ability to use purely logical addresses, no topological constraints because of the mapping system, and Lisp ability, if you go down, to do channels, multicast channels, which are good for millions of channels for thousands of users, very good for if I reduce data to indexes, then I can subscribe to those indexes, and this subscription is for a much more portable feed than the raw data after reduction. Okay, so this is why Lisp, out of all the overlays out there, it's very ready. Next slide. And this is the, what is the Nexagon? What are the tiles? Every problem will have its own tiles. The tiles of cyber is the flows, the 5-tuple flows of masks. So if I'm scooping thousands of 5-tuples out of millions, then in multiple points in the network, they will still be steered to the same location where they'll be reduced. The distribution of the flow, the Bayesian behavior will be learned, visibility will be reflected, and the surprise will from what is expected, will create hyper attention. So this has been very successful. It was able to, it's very easy to put on top of a network, and it was able to detect DDoS like a minute before a firewall. Next slide. And this is the reduction factors. Next slide. I mean, I want to get to the gist of it. Okay, this is the gist of it. Is we use Lisp for this pattern. We take a problem, we pre-divide it algorithmically to something that can be addressable. We steer the raw samples to these addressable contexts. These contexts apply reduction functions, and then we subscribe to those. That's it. So if the point here is that if there is interest in the group to further develop this in line of what Luigi presented and other use cases, then it would be good to know. And if anybody wants to help on that, very welcome. That's it.
Okay.
Thank
you very much, Sharon. If there are any questions or comments from the audience.
Okay, so I have a question, Luigi.
Yes.
So given that, we want to mark this and move on to generalize to that every problem can have its own tiles and own channels and feeds, then I want to finish the Nexagon draft to be an RFC. And the question to you and Joel is, do we have to wait for the BIS to do that, or we can just publish it as is and then refer to the BIS in the generalized draft? So we can just, you know, as far as attention, ADHD.
If we try to publish any Lisp drafts that are pointing at the current experimental things, even if those drafts are themselves experimental, the IESG is going to look at us and go, wait, but you're having us work on all this other stuff. I understand why you want to get it done, Sharon. I sympathize, but I really think we need to be pointing at the BIS drafts, and that we will. But you can point at the BIS drafts, get everything done. We're close enough. Don't worry about the time difference.
Okay,
So
so you,
just a quick, this is Alberto, just a quick comment. And I don't have an opinion, I just raised the point. The intended status of Nexagon right now is informational, not experimental. So I don't know if we still have to wait for this. I'm perfectly fine waiting, but you know, I don't know if we need to.
My personal opinion, honestly, is even if it is informational, it would be better if it points to the BIS documents, because it is just for more credibility for the content. Because at some point somebody could read and say, yeah, but it's based on the old specs, not the proposed standard. Okay. The work going on, we are close enough. The worst case will sit a little bit in the editor queue, I don't know, but this is real, my personal opinion, not a shared opinion. Okay.
all right, so guys, I think you know, it's your considerations, your decision. I understand what Joel said. Just be aware of the other side of it, which is if you want to hand off this Nexagon as an RFC to organizations like AACC, the Auto Edge, anything IETF is already not their industry. It's not like dealing with Juniper and Cisco and those. And at a minimum, it has to be an RFC. So until then, you know, it's really delaying it. So you know, just observe the progress, and if it's reasonable, then fine. If not, just make a call. Up to you.
Again, I will give you my personal opinion. Okay, the BIS documents are very, very close to be done.
Okay.
Close favor. So
Okay.
I would wait a few weeks just to see. Albert just submitted new versions. Maybe today or tomorrow they clear all the discuss. If not, next week I team as a chair to please have a look to the new versions. Okay, so maybe in a couple of weeks these documents are through. So if you move your document right behind, it's just 2 weeks delay. I mean, it's not a big deal.
Okay.
But again, this is my personal opinion.
All right. That's a very good news by Christmas. Thank you.
Let's cross fingers.
Thanks.
Okay. Okay. So let's, unless there are other comments or questions, we move forward. It's time for Dino. For encoding names. I'm putting up your slides.
Can you hear me okay?
Yes. Here we go.
You can hear me okay? Hello?
I can. You hear me?
Yes, I can hear you. Can you hear me?
Yes, I can.
Okay, great. Okay, so I'm going to talk about the, I guess, the 11th revision of the list name encoding spec. Next slide. So an overview of the spec, it's an extraordinarily simple spec. Basically, this is a compact way of encoding an ASCII string in either an EID record or an RLOC record. There's an AFI that has been defined before, AFI number 17, that's called a distinguished name. I thought the draft could use that, and we could encode names in either of those records. It's much more compact than LCAFs, and and it has much more flexibility than LCAFs because it's shorter, and these things will typically be nested in other things. So the shorter the better, make the packet sizes smaller. What's the advantage of distinguished names is that you can provide a self-documenting set of mapping records in the mapping database. Since I've done my implementation, it's been 8 years now, that these names are lifesavers in debugging problems and maintaining systems. Very much, the idea is not very original. It basically came from ISIS first and OSPF second, where you could put host names to name LSP IDs in ISIS PDUs. Those were, in the early 90s, those things were invaluable tools. And I thought we could use something inside of Lisp to do that here. And it also allows you to do these groupings if you wanted to have a name that maps to other things, to other names, which then maps to traditional RLOCs or whatever the LCAFs can be. You could set up a multi-stage lookup if you chose to do so. And it turns out that the names could be formatted in a way where they fit into a hierarchy of Lisp DDT. So, for instance, a lookup of /root/dino/slide/Bangkok, which is a fully specified EID distinguished name. The root could, parse the /root/dino because that's the authoritative prefix at the root level, and then point you to a set of children that are the next level, like slides. And then the next level would be Bangkok, would be the map servers. So there's no changes at all that have to be done. Lisp DDT, you just have to configure the authoritative prefix to be the set of characters versus the set of bits that we use for IPv4 and IPv6 EIDs. And the same goes for supporting Lisp Decent. Lisp Decent is a way of hashing the EID to pick a map server to register to, or a map resolver to send map requests to. So since it's since it's just a set of bits, you can still hash across that to pick a map server. So the decentralized Lisp mapping system works with 0 changes as well. And map request lookups usually are doing exact match typically. So if you have a fixed name, or you're using maybe a hash of a public key where it's been defined as being fixed length, you're always doing you're always doing a length with a mask length, and you're always getting the map reply back with the same mask length. That's what I meant by exact match. Next slide. So here's an example. If you look at the top, this is the EID prefix that's being registered as G-XTR1. The actual mask length of that would be, 1, 2, 3, 4, 5, 6, 7 times 8, so 56-bit mask length that would be stored in the system if you wanted to use the same concept as IPv4 and IPv6 mask lengths. Now the RLOC name that you see down there that's called XTR1, that's encoded in this RLOC record as an AFI list, where the first item in the AFI list is an IPv4 RLOC or an AFI, and then the second one is the AFI 17. So this is a representation on how a LCAF AFI list would be encoded. So an example of something being nested. Next slide. So the changes that I put in to reflect the comments that came on the mailing list was describe better how the mask lengths work in each of the messages. So I did that. And then I added a use case section saying that we have some examples that use distinguished names, and those 3 documents there are examples of using distinguished names. I also added a name collision consideration section because a distinguished name can be, the structure of a distinguished name can be decided on what instance ID you register to the mapping system, and the mapping system could decide what it is. Joel had a comment that if there's 2 different types of distinguished names registered, will they counter conflict with each other? And if they would, they would have to be in separate instance IDs, just like 2 two houses that are behind that use 192.168.1. Those two things are registered to the same mapping system, but they don't collide because they're in separate instance IDs. Next slide. So we started the draft in April of 2016, and we're now at the latest draft that I just submitted a few days ago is 2020. So this very simple 7-page draft has been going on now for 4 years. Next slide. And if you look at what we did is we had the initial submission there on the right, which is in green, and then we just spent a good, 1, 2, 3, 4, 5, 6, 7, 8, 4 years of just updating the changes to the draft. And so, maybe it comes to a point where you have to ask, why has the progress been so slow? There is utility. There has been some support. There has been commentary over the course of the 6 years, and there's really has been no strong objections. So I'm wondering why this.
Once I went and looked, I have to disagree with that. Once I went and looked carefully at this, I do have strong objections. What is in here are not distinguished names. And as I've said on the list, the solutions you've proposed are not good enough. This is I can just dump an arbitrary string in and, well, it'll work with my use cases, and as long as everybody's careful, it'll work, but I can't tell you exactly how to be careful. Other protocols that have done this have gotten into big trouble, and I really don't want us going down this path.
Well, I have no reply to that. I don't know what your definition of a distinguished name is, but I'm using that term because it's assigned to AFI 17. What it is a ASCII encoding, or can be a Unicode encoding if we use a different AFI, but it's just a string. And it's no different than a DNS name where you have to coordinate what the value is. So I don't know what the big deal is.
DNS names are structured. DNS names are structured.
Yes,
and so they are distinguished. These things are not distinguished. They're just arbitrary strings.
I'm not calling them distinguished, Joel. I'm saying that
the AFI is distinguished names.
On the particular use case, they have to have structure. And if you look at the ECDSA draft, it shows an encoding where you do not have collisions. And it's as simple as that. And if you think another use of it's going to collide with that specification, you don't run it in the same instance IDs. So these are very solvable problems. So I don't know what the objection is.
No, they're not. Fundamentally, you're expecting everybody to magically know all the other uses without defining how to distinguish it.
Those drafts say how the names are supposed to be encoded. That is specified in those drafts. Go read those drafts, okay? Give me specific comments, please, rather than I don't like it because it's been done that way before.
You're missing my point. Yes, the usage draft specifies how to encode it, but this draft doesn't specify what the requirements are that must be met so that things are distinguishable, so that different uses don't collide. And don't think that they might collide into different instance IDs is not going to work for writing other specs. It requires magic knowledge.
It does work, Joel. I don't know what the problem is. They won't collide if they stay separate. Why do RFC 1918 addresses not collide?
Collide.
No different.
That's a big problem.
But it works. The system works. And we keep them separated because we have virtualized networks. That's how it works. Next slide, please. So this is my third attempt, at least, to request at least the working group to work on it. So it's not like we have to make this an RFC right away because we can't do that anyways. But does the working group want to work on such a feature because it's actually useful, and it would be nice to build practical solutions. It's only a 7-page spec, and we can comment on it as a working group draft. We had support on when I sent it out a few months ago. There was support. The chairs thought there wasn't support, and then Joel decided to read the document and then objected to it. So we have had support. Okay.
On that, I have to disagree as well, Dino. I'm sorry, but so the.
What do you disagree?
Let me try to explain my concerns. Let me try to explain. Okay. So the point is the document has not been really evaluated by the group. You had once you presented the document, then you had several updates, etc. But what happened is that you moved forward the document. At some point, you said it's time for the working group to adopt this document.
I did not say that. I never say that, Luigi. I have to clarify. You always tell me that I say that. I request the working group to consider it as a working group document.
Yeah.
Okay.
Okay. Fair enough. The point is that why my feeling.
And if we make a working group document, more people will review it. And it's not till you take an action that causes an action from somebody else. And Joe was an example of that. And I appreciate the comments.
Dino, wait a second. So the point is, to become working group document, there must be some interest. People have to see the interest in the document and say, I need this. Okay. So what happened on the mailing list was more about, well, yes, why not? Okay. This is my question as a chair
you're
about the
making
document.
a suggestive comment on the type of support. Okay. There was support on the list. People said it should be a working group document. For some reason, the chairs are deciding to ignore that.
No. That's not fair. I'm trying to see what is happening. So there is some concerns about the document. What I suggest is that you and Joel, you really try to discuss what are the concerns and what are the technical issues concerning this document, okay? And then we go back to the mailing list and the working group and say, these are the issues that Joel had, and does anybody has other concerns? Are people really interested in having this in Lisp because you think this is a feature that Lisp needs? It's not a feature that you need, and it works for you when you are alone in your implementation. Something that has to work with the internet and the Lisp as a whole. That's my point. Okay, if we reach this level of specification, because in my opinion, the document, I told you this on the mailing list, is underspecified. Okay, there are missing pieces that maybe they are clear in your idea, but are not written there. Okay, so
I would like to receive specific comments, please. Okay, rather than just making high-level comments.
No, I did it on the mailing list. I did it on the mailing list. I didn't read your last version of the document, to be honest. So I cannot say if they have been addressed or not. I will read your.
Well, you have
again,
to tell me that.
and I will send you the specific remarks. This is not a problem. It's just that we need the document to be clear, okay, and well specified. Then we move it on and to really check if the working group is interested. Keep in mind, this is the point, being interested, because it's not that I write something concerning Lisp, and I say, okay, the working group needs to adopt this, should consider adopting this document. Okay, it's about the interest. How useful is for Lisp? I understand from your perspective, it's very useful, but it's about the working group. See what I mean? So,
well, we have other implementations of it too. I'm not the only one using the implementation, so.
Okay,
right.
maybe I'm missing something, and we will work in the coming weeks to clarify everything. And then when especially Joel has strong concerns, we work on this, and then we move on. We check what the working group has.
Yeah, I mean, making it a working group document does not mean that it ends. It means it's beginning. beginning.
You know,
Dino,
I
let
think-
Fabio comment, please.
I just wanted to make a short comment. Sorry. So, Dino, looks like the Joel has some specific objection, right? Probably it seems that the word might help from him articulating better what are the objections. So I think at this point, the suggestion that Luigi is giving is spend some time with Joel. If the two of you sit down and you try to basically understand what Joel is saying, and Joel is trying to articulating in more detail what are his objections, that will eventually lead to, having more content for your document. So I don't see how that is detrimental, right?
We have started that process, and we had one round, and the document was written, and Joel's not satisfied, so we have to do it again. So that's all there's to it, right?
Yeah, that's how it works, right? Sometimes.
Yeah. And then we will check if the working group is interested in this work. I hear your voice. You say it is, but we have to check it as for the usual process. Okay. Is it okay for everybody if we proceed in this way? Or does anybody has further comments? I invite you, all of the people, to read anyway the document, and beside the technical concerns that you may or may not have, make up your mind if whether or not this is something useful for Lisp and the working group. Okay.
So, quick comment there, Luigi. Yeah, sorry, I haven't spent the time maybe I should on this document, and I don't have the expertise. But my personal opinion as a working group participant is that this could potentially be something useful for the protocol. So I would definitely like to see the discussion going on, and whoever wants to chime in on the technical details to do so that we can start this further.
Okay. So you see potential in this document. Please read it, and the more voices there are there, the better the document will be. And so review the document and send any concern that you have, or if you don't have concerns, you say, for me it's good. I can implement.
I mean, Alberto said that on the list that he supported it as well as other people. So I hope you saw that level of support.
Yes.
There were a half a dozen messages, right?
Nobody said that nobody is interested. Try to understand. It's just that we were not able to declare a strong consensus, and there were technical concerns about your document. That's the point. We can work on the technical concerns and make a full normal checking whether or not the working group is interested. That's it. Simple as that. That's okay for everybody. Okay, let's move on in this case. Last presentation. Put it on. Jordi. Here we go. Hi, Jordi. I cannot hear you. Doesn't look like you
In the
put on
top
the
of
mic.
the panel.
Okay, you have to click both buttons. Okay, I thought
exactly.
that. Okay.
We hear you now.
Okay, great.
Thank you.
And I hope you can also see me.
Yes.
Okay, so in this presentation, we'll show how we use Lisp into real-life deployments. This presentation is based on a paper that you can find here in archive. Can you click the next slide, please? So, well, basically these deployments are part of a larger product that it's for enterprise and campus networks. And well, first I will give a quick overview of this product, and then I will explain why we use Lisp for this product. I will also give a quick overview of the design and architecture, and I will end up with some evaluation details. Next slide, please. So SDA, or Software Defined Access, is a product for campus and access networks, and well, it does several things, but it basically has a VXLAN data plane, and it uses Lisp as a control plane, and it treats wired and wireless traffic in the same way. And it's basically it's aimed to support the requirements of current enterprise networks. So in short, it's mobility, segmentation, and resource efficiency. And also it provides segmentation in two orthogonal ways. We're using the VXLAN BNI and also group-based policies. Well, this is quite a widespread standard in the industry, basically mapping IP addresses to a group and then enforcing policies on this group. And it also provides layer 2 stretching. And we also use some Lisp capabilities for that. Next slide, please. So why did we use Lisp for this product? Well, first of all, to provide mobility, both layer 2 and layer 3. Also to reduce and distribute the data plane state. And especially to reduce the data plane state. So our main goal is reducing capex. So basically, if we have less entries in the data plane, we need a smaller feed. This means less memory, and this means cheaper routers because they will need a smaller chips or memories or TCAMs or whatever they are using. And also because we can, with Lisp, we can provide incremental deployment. Basically, we can leave all routers in the underlay and just update the ones that are using Lisp. Next slide, please. So, a quick note on the architecture and design. Can you switch? Sorry, I was thinking I would be able to click them from myself.
No problem.
So, we use the standard Lisp with a few tweaks. As I said before, we also use the VXLAN as a data plane. And we tag endpoints individually, so that means that all EIDs are /32s. And we store 4 mappings for each endpoint. So we have their IP version 4 address, IP version 6, MAC address, and then we also have a mapping of MAC EID to IP EID, and we use that for layer 2 stretching that I will explain it later. Next slide, please. And regarding the wireless part, so basically to paste or to join Lisp and wireless, what we do is, on one hand, we connect access points to XTRs, and on the other hand, we connect the VLAN controller to the map server. So this way, when the VLAN controller detects that the host is doing a mobility event, it sends a map register to the map server, so the location is updated. And also, I have to mention that we add a VXLAN tunnel between the XTRs and the access points. But next slide, please. Well, we actually, however, this VXLAN tunnel I was mentioning between the access point and the XTR is different from the ones in the underlay. So the one in the XTR, between the XTR and the access point, is just to be able to have several access points in the same XTR. But this information is not propagated in the mapping system. We just have the regular ones from the underlay. Next slide, please. So I will explain just a few details about how we handle all the mobility with the wireless stuff. As I said, we have this static VXLAN tunnel. Basically, we needed to carry the layer 2 frames between the XTR and access points. And we also, what we also do is we store the IP of the access point and the XTR where it is connected in the map server. We'll see later why we need that. And when the VLAN controller detects a roaming event from an access point via the CAP web protocol, as I said before, it sends a map register to the map server to update the location of this endpoint. And here is when the mapping of access point IP to XTR airlock is useful, because so basically we do first the VLAN controller does a map request to know the XTR airlock of the new access point, and then it does the actual map register of this endpoint. Next slide, please. So once we have updated the location of the endpoint in the map server, the new XTR receives a map notify in order to update local state, so traffic can reach the new host. And also we use a couple of mechanisms to improve connectivity. They are the away entry and the SMR. And I will, well, can you switch to the next slide, please? And basically what we do is we use the Lisp SMR. If an XTR receives traffic for an EAD that is no longer in this XTR, it sends an SMR to the origin XTR so it can update its map cache. And well, how does this XTR know that the EAD is no longer connected? Well, we have the other mechanism, the away entry, that basically remembers this information. And also the away entry, what does is tell the XTR to forward this traffic to the new XTR. So well, it's what you can see here in the graph. Basically, the away entry, instead of dropping traffic for an EAD that is no longer present, it forwards it to the new XTR. And I think that's all. Next slide, please. Oh yeah, and finally, a design note about the resolution delay. As you know, we have a small delay until we resolve a map request. And to avoid dropping packets during this time, we use this Lisp configuration. First of all the XTRs have a default route to a proxy XTR, but this proxy has also a variant of the publish subscribe draft active, so that it always is synchronized with the map server. So in other words, the proxy can forward traffic to any destination. So this way we can forward the packets until the map request is received in the XTR. So this way we don't drop any packet. And we also use this proxy to provide external connectivity. Next slide, please. And well, finally, just a few notes about layer 2 stretching. I mean, by layer 2 stretching, I mean that being able to extend layer 2 domains in a scalable way. This is something that is quite useful for enterprises because sometimes you want to avoid ARP broadcasts propagating through the whole network, and it's especially important in medium and large deployments. Also, you have some layer 2 protocols that require layer 2 visibility, for example, Apple Bonjour. And also, it's very common that to have legacy IoT devices that are not using IP, so you need some way to connect them. And well, what we basically do, it's quite simple and straightforward. The source XTR encapsulates the layer 2 frames to the destination XTR, because we can do that because we have the option of in the XLAN. And we use the map server to resolve the missing information. For example, we use the destination MAC address to know which XTR has this endpoint. And we know this because we registered previously in the map server both the IP address and the MAC address of an endpoint. And also for being able to propagate IRP requests, we use the MAC to EID mapping. No, so this way we can know which EID corresponds to a specific MAC address. And well, just as a small note, we forward all IRP requests instead of creating them. I mean, the XTR could respond to some IRP requests, but we forward them for coherence with IP version 6 NDP. Next slide, please. So, well, I provide some results that prove more or less what I've been saying until now. Next slide, please. So the first measurement we performed was trying to prove that we could reduce the data plane state. And what we did was count the map cache entries in the proxies and the XDRs. Since, as I told you before, the proxy has all the map server data, we should be seeing in the XDRs just a fraction of the mappings that has the proxies. And we have data from 2 deployments. You can see here the topology, which is quite simple. I'm not showing the underlay for clarity. We have a deployment with 150 hosts, another one with 450 hosts. There are usually 2 proxies for redundancy, 6 XDRs, and approximately 20 access points per XDR. Next slide, please. And here you can see the results. These graphs plot the average number of map cache entries for IP version 4 EIDs, for the proxies and XDRs, for the 2 deployments, and for 2 weeks. And you can see that usually we have more entries in the proxy than in the XDRs. Next slide, please. And specifically, you can see that in the first deployment, we have a 50% reduction in the data plane state. And in the second slide, we have an 80% reduction. Next slide, please. And well, just some other things we can see from these graphs. For example, you can see that deployment B, there is an amount of devices that are always connected. And well, these are IP phones, if I recall correctly. And you can also see that the proxy, since using PubSub, or well, actually a variant of PubSub, it's always following the workday schedule. No? For example, you can see that there is no one during weekends, and you have all these spikes across the weekday that they go down when people leave the office, because we're talking about an enterprise network, so people come and go. And also you can see in the Saturday afternoon, here in the top right, you can see like a large drop in the number of entries in the XDRs. Well, this is due to the fact that we are using a 24-hour TPL for the map cache. So more or less Saturday afternoon, when it's a day after people have left the office, all these entries get evicted. And you don't see this in the proxies because since they are synchronized, when an endpoint leaves the office, it's very probable that it's very possible that someone wants to talk with it, and since this endpoint is no longer in the network, it will receive a negative map reply, and it will get deleted from the map server. Next slide, please. And finally, we related the handover delay. We simulated in the lab the conditions of a real-life use case. Specifically, it's a warehouse with thousands of mobile robots going around. And the setup consisted of 3 physical routers, 1 proxy, and 2 XDRs. We also used a traffic generator to emulate roughly 200 XDRs, and they were all generating traffic to an external network. And also we used the traffic generator to create handover events between the 2 physical routers at a rate of 800 moves per second. And this was a requirement of this deployment that I was telling you before. And next slide, please. And you can see here the results. So we measured the handover delay for the Lisp control plane and also an implementation with a BGP control plane. And you can see there's a difference of approximately 1 order of magnitude. And this is due to the fact that Lisp only notifies the routers that need an update for the routes, while BGP needs to send updates to all the routers. And also, you can see that this also creates more variability, no? Because it depends on the moment that BGP receives this update, and then the connection will restore. So you can see that there is much more variability in the BGP delay than in the Lisp delay. Next slide, please. And that's all. In conclusion, we presented an example of a Lisp deployment in a private setup. We have shown how Lisp can be used to reduce data plane state, and how we created a distributed mobility data plane. when we compare this setup to the classical VLAN controllers, we have improved routing because we are not sending traffic to the VLAN controller and back to the network. And also, this makes it possible to scale better. And so we have shown how it can reduce the mobility handover. And I think that's all. Next slide. But yeah, thanks. If you have any questions, I'm happy to answer
Thank you very
them.
much, Jordi. Any questions or comments from the audience? I actually have one. Oh, there is Alberto. Let's go ahead.
Yeah, I just have one quick comment. I wanted to say that so Jordi has done a great summary of the paper in the presentation, but the actual paper that is available on that link that is in the screen has all the details, and it's a very interesting read. I mean, I'm not biased, right, because I'm on the author list, but it is a very interesting read for anyone that has been working on the Lisp protocol, because it really shows Lisp in action in a real world deployment, actually different real world deployment. So I invite everyone to go ahead and read the paper, the evaluation section. It's really, really interesting. There's a lot of insights on how Lisp behaves in several real world scenarios.
Thanks, Alberto.
Thanks, Alberto. I switch back to my question. So it's a nice piece of work that you did, first of all. It's very interesting. And you seem to rely quite a bit on the MAC address. Okay. Now that works very well in enterprise networks, but if you have a more public deployment, let's say a huge campus that wants to give Wi-Fi connectivity, now maybe you will connect using iOS or Android, and I discovered this week that they have features to change dynamically the MAC address because of privacy reasons. Okay, so maybe you don't have an answer right now, but have you thought how can you comment how it would work if there is this thing of dynamically changing the MAC address?
Well, that's a really good question. I should probably think about it because I couldn't attend the BOF yesterday. And also because I'm not very savvy in the implementation, and especially because we left I think we have Mark here that can comment more on the implementation, but so Lisp is just something on top of all the layer 2 parts, so it's not doing.
Yes.
So I guess it would be. I really don't know how we would solve it, but I think it's a problem that everyone would have also still, because it's not Lisp specific.
No, it's not Lisp specific.
Oh, no, it's definitely not Lisp specific.
No.
But for those who are tracking the missing pieces, there was a BOF called Madinas, Madinas, yesterday, driven by a bunch of work over at IEEE on randomizing MAC addresses, periodically changing MAC addresses, and what that does for IP activities which depend on MAC addresses. And obviously, Jordi already knew about it, but other folks might not, so I want to just fill in the other bits.
Yeah, hi, Mark here. Actually, we have started discussing how to address this problem with the SDA solution. There are, and this was explained yesterday in that BOF, there are multiple approaches to randomization of MACs. I would say that thanks to the way that Lisp works, multiple of those use cases could still be handled well. The most extreme one, though, I think it's the one that Apple has implemented in some of the latest iOS, where they really randomize, or they really generate a different MAC address every time they change access point. and this is the one that we are studying now. But there is this mode in SDA where you can work L3 only and just use IP addresses as identifiers. That could be one possible first approach, but still, yeah, some work to be done there. And as you say, right, it's affecting everybody, right? Not just Lisp.
Yeah.
In general, having a centralized database, right, for the MAC and the IP that are the table that you have, Mark, that probably makes things a little simpler. Keeping in mind that, sure, if you change the MAC address at every change of access point, then yeah, I mean, you need something in the protocol or something.
Yeah, actually, it's interesting. I mean, it's what you say, right? From an scalability perspective, the solution just holds. The main effect is in mobility, right? The problem is that this guy that randomizes every time that changes access point needs to re-authenticate again, and this affects the speed at which things happen. But yeah, the way SDA has been designed, you can detect that the guy is the same, right? Once it re-authenticates, so
True.
the database is able to hold it.
Sounds like the problem is a MAC address is being used as an EID, and when you reassign EIDs, that causes problems. If you just run layer 3 over this, you don't care what the MAC address is. So it's it could be arguably a misuse of layers, right? And the problems with traditionally we have with layer 2.
So yeah, well, I mean, one level of indirection is good. If you then start scrambling the tables randomly, then it makes everything harder. That's true.
Yes.
I think
Well,
one important.
I mean, Fabio, I don't think there's a problem if you just randomize the MAC address as long as it's not being used nowhere else but locally, like on a layer 2 LAN, right? So,
Yeah.
I mean, I don't see the problem. The fact that you want to build L2 overlays means that problem now moves into the overlay. That's the problem.
Yeah, exactly. That you bring it up for mobility. Yeah.
One thing to highlight is what Mark just said, that on SDA, that is the solution that this paper evaluates, you still have an authentication to be allowed into the network, right? And on that authentication, you have to establish your unique identity against the system. So it's not going to matter on this particular solution what your MAC address is or how random it is, because the system still needs to evaluate your identity, and it's going to assign you an IP address that it can potentially be the same no matter where you're connecting from or which MAC address you're using. So there are other systems in place that is not just the layer 2 MAC address.
Well, maybe this makes in the future, maybe they also randomize IP addresses, and then we'll have a problem in another layer.
Yeah.
Yes. So
We'll have
this
less
will
of
be
a
good for
problem.
privacy. But
I mean, the EID anonymity draft basically says that's a feature by randomizing an EID, and that you can use multiple EIDs at the same time and phase them out. And since you have a mapping, you know, they can be added to the system a lot easier when you're on an overlay. So it depends how often you're randomizing it, right? That's the thing. Because I mean, a randomized EID is no different than an EID that's statically defined to some node that now comes to a new place in the network. It just looks like a mobility event and a new binding with an RLOC, right?
Okay. Thank you very much, Jordi. Unless there are other comments or questions, we are over with the presentations. Okay, so we have something like 15 minutes to the end of this session. If anybody wants to raise any question or general discussion that we we want to have here in the Lisp working group.
Are the RFC numbers going to be assigned soon to this document?
Sorry, I didn't catch what you just said, Dino.
Will RFC numbers be assigned relatively soon to the BIS documents, since it's going to go into the RFC editor queue in a couple weeks, as been stated earlier?
Well, A, we can't be sure. We're hoping it's going to go in soon. We're close. B, then it depends on the work queue at the RFC editor, and we do not get to tell them what the priority is. And
yeah, I remember
that queue's been
previously that
backed up.
once it goes on the queue, an RFC number is allocated, and that you could start referencing it. I'm trying to address Sharon's concern. So we could still write documents that reference the BIS, but we can start referencing the RFC numbers, and we could have some parallelism or concurrency while it's sitting in the editor queue, and we're doing all the editorial comments with the RFC editor. Right?
But
Do you believe that?
we don't even need the number for that, The RFC editor will happily correct a reference to the BIS drafts into a reference to the RFC number during final edit. So we don't even need the number.
But not to all the documents that are referencing it, right? Like working group documents and individual submissions. That's what I'm talking about.
But we're really not supposed to use those numbers until they're really permanently assigned. They can get changed. So I'm not sure what problem you're trying to solve. I'm sorry, I'm just not following it.
I want the documents that depend on BIS to be rewritten that are going to go fast track right on its heels, that the editing could be done while we're waiting for the RFC editor. Trying to build some concurrency instead of serialization.
The RFC editor will fix all of those documents when we hand them over.
Yes, anyway, you have to go through the RFC editor. So
even if it's an informational, that Sharon wants to do next year. Okay.
And even if it is,
they still go through the RFC editor, and the RFC editor will fix all of these.
Yeah, no worries for that. They will fix it.
Informational RFCs still go through the RFC editor.
Yeah, but I remember all the documents. I remember in the past when we had 6830 that the current documents we were working on had to be changed, right? And they will. The ones that have not been sent to IESG yet, that's what I'm talking about. Because those things tend to have long lifetimes, and you'd like to point it to the latest specs. So the working group documents are going to have to be modified by us, not by the RFC editor.
Maybe you refer the fact that you had to switch it from the 6830, for example, to 6830 BIS. This is a change.
No.
And
I'm talking. It's way before that.
Yeah. Okay.
And the reason is because the BIS documents eventually go away and they're not referenceable anymore. That's what I remember. But anyway,
I think you're misremembering.
It would be good to know as soon as possible, also for IEEE papers and things that have like deadlines and they're published like much later. So as soon as we have
that's where I wanted to be careful, because a paper going to IEEE should not be referencing an RFC number for an RFC that has not been published, because we don't know how long Auth 48 will take. We can't make commitments no matter how much I want to. Look, I want this stuff to be done. I understand we all want it to be done, but we got to go through things in order.
Yeah, we cannot have commitments on the deadlines because that's the way IETF works. Yeah. Okay. Any other question or issues? Otherwise, we can say goodbye. I'll go grab a cup of coffee that I really need. Fabio, go ahead.
No, just wanted to say good night, everyone. Thanks for keeping the meeting going, Joel and Luigi. You do a lot of work, and thank you.
Okay. So in that case, thank you all. The next meeting will be again in virtual in the European time zone, because it was supposed to be held in Prague. So a little bit easier for the American people, time-wise. So anyhow, have a good evening, good day, good morning, and stay safe. Okay. Bye-bye all.
Thank you, guys. Bye.
Thanks, bye.
Bye. Thank you.